Hey everybody, going to set up this little Regents review uh, assignment for you. I think it'd be kind of fun actually to do this and hopefully be pretty beneficial. We're going to make a shared um, review document, right? You're going to put practice problems in there. I might put some notes in there for you, kind of as we go, maybe like a summary section. Maybe put some screenshots of the relevant physics equations from the reference table in there, that sort of thing. We're basically going to work through the reference table, really, on the back page mostly, and get her done. So what you're going to do is you're going to go and find old Regents questions from wherever, and I'll show you where. There's a link in the review topic here, right here, Regents exams, right? Um, you're going to go ahead and find questions in here. Um, you may not use the same questions that other people have used, okay? Uh, you don't have to go too far back to find enough kinematics questions to not repeat, but further topics like circular motion, momentum, you will have to go farther back to find questions that other students aren't using. So what you're going to do is pick a Regents, try to find a problem that is from the topic that we're doing. So our first topic we're doing is one-dimensional kinematics. All right, so I've already prepared one. I wrote a solution off screen. But anyhow, I know which one I'm going to pick, but I'll kind of help you select. So I'm going to go back to June 2008 because that was the first year I had students take a Regents physical setting physics exam. That's that. The answer booklet is the sheet that you write your answers in. And this is where you're going to look to find the right answer. So I already know which question. And now that I'm thinking about it, I probably should double check that I got it right. Yes, number 5 I'm going to do, which is 3. But anyhow, uh, the answer key is there. But you don't have explanations. And we're going to stick with the multiple choice questions here, guys, not the short answer. So now let's go to the exam. We'll take a look at the one that I chose. But first, we'll kind of start reading through and try to identify if some of these are one-dimensional kinematics. Well, this first one is a one-dimensional kinematics question, actually. I thought about doing that one right out of the gate, but I wanted to show you a calculation one. This you would have to write a couple sentences about what it is. So the speedometer in a car does not measure the car's velocity because velocity is well, whether or not it's a vector quantity or scalar quantity, I mean, one of those is true. Velocity is a vector quantity. Speed is the scalar. So it's got to be one or two. And basically, this is just defining a vector quantity because a vector quantity has direction associated with it. So the right answer is number 1. A speedometer measures speed, right? The speedometer doesn't tell you the direction you're moving in. It just tells you how fast you're going. And you might be turning and it's still, the speedometer doesn't change. But your velocity does technically change because you're changing direction of motion. So if I was going to do a conceptual one, which some of you might prefer, um, I could see some personalities in the class who will like to write a couple sentences rather than showing the work and the calculation. I'm thinking burger. Um, but for this one, I would say, okay, a speedometer measures speed. Well, how would I say this? It does not measure cars because velocity is a right answer. Okay, so speedometer does not measure the direction a car is moving in, right? It only measures how fast it is moving. And velocity requires direction, something like that. Put it all together. For this one's kind of weird because you're just restating the answer here, the right answer. But anyhow, so projectile launch, no, that's going to be two-dimensional motion, which is going to be our next thing. Inertia, no, that has to do with mass inertia. That's later. How much time does it take light to take travel sun to Earth? That is one-dimensional motion technically. You could figure that out, but that's actually a little bit beyond what we're doing. We didn't talk about light. Number 5, a rock falls from rest. A vertical distance of 0.72 meters to the surface of a planet in 0.63 seconds. The magnitude of the acceleration due to gravity on the planet is, okay, classic one-dimensional motion. So this is the one I wrote up. So what I'm going to do is take a screenshot of it, or a screen capture. Now I'm using Windows. You guys from the previous assignments, looks like everybody figured out how to take screen captures of somehow. So I'm going to capture this problem. But what I'll tell you is you probably want to zoom in on a little bit first, which, maybe it's hiding on me. Oh, there it is. My face is in the way. So I'm going to zoom in here. It just makes it a little bit easier to see what you're doing. Got to move my face out of the way. Then I'm going to go do my snipping tool, which is what I prefer. Snipping tool. Snickerdoodle. What the? That's weird. Oh, I did SNI. See, bizarre. Snipping tool. And then I'm going to capture. I'm going to do new. Everything goes white, and I'm going to capture it, but I'm not going to get the number in there. I don't want the number. I don't know. I just want it to look nice. I'm going to capture it pretty tight. All right. There we go. And then I'm just going to edit, copy. Now, I already have the shared document open over here. All right, get my face back out of the way. And I already started it, submitted by Griffin Harmon, June 2008, number 5. So you're going to have access to the same document. I'm going to hit return here. I'm going to hit return again, give a little space. I'm going to Control V, paste my thing back in there. It's huge. I don't want it that big. I'm going to shrink it down, about half the page width. All right. About half the page width, shrink it down. They're all in columns like this, right? So when you capture it, they're all going to be the same size. Actually, I shouldn't say that. Some do end up being a little bigger. So if you use one of those, it can be bigger than half the page in terms of width. Try to make it same size it was on the original paper. All right, so you can definitely pick these bigger ones. That's fine. Your solution, you'll just have to paste underneath it. All right, so I already wrote up the solution. So now I'm going to go over here. I'm going to insert image, and I already put it on Google Drive. So I'm just going to hit Drive. There should be some recent files over here. Yep, I used Cam Scanner on my phone because this. Let me show you the difference. This one, well, I don't want to. Actually, let me just show you the difference over here. This one is one that I just took the picture and I cropped it, which is fine. That's totally fine. And I shared it to Drive, and that was there. That's totally fine. But this one I did with Cam Scanner. It just makes a little higher contrast. I did Cam Scanner. It does that magic filter on it. Makes it look nice. That's fine. So I'm going to pick that one. The face is in the way here, which I just love. Let me select that one. This is annoying. Insert. Makes it huge. That's all right. I'm going to shrink it down. Just make sure, I'm going to shrink it to about half the page. All right. I want it to be up next to this, right? How do I get it there? How does this work? Oh, man. Oops. We got to fix that justification. Now, Word does this much nicer. Unfortunately, you can't just move it wherever you want it unless you get it just the right size. I mean, I guess I could shrink it down a little further and it probably will fit in there next to it. But yeah, I want it next to your problem that you selected somehow, however you want to do it. You can select, I think you can just do fixed position, move with text. I don't know. It's a pain. I know there's a way to get it to move. Now the problem is sometimes when you hit return, it'll move the whole thing. So I'm going to put it right there. All right, and the next person who comes up, all right, whoever that is, you're going to put your name, submitted by, oops, now that's bold. I don't want that bold anymore. And this doesn't need to be bold here either. All right, I don't know why I made that bold. The next person, submitted by, I don't know. Let's say Sophia, somebody's name I can spell without having to look it up. Sophia Silver, submitted by Sophia Silver. And unbold it. That's fine. And then whatever one you pick, 2019, number 3. You know, get your screenshot in there, get your solution in there, and you're done. That's your assignment. All right. Don't mess up the formatting. Try not to. I know that's going to be a pain. Maybe I should set up a table. That might be easier to put one in each cell in a table. I'm going to think about that. Actually, that might be the way to go. But anyhow, that might just be even more confusing for most of you. There you go. So if you have a really big problem, then fine, just place your solution below it. We're gonna break this up into topics. So I'm gonna call this one-dimensional kinematics. Then we'll do projectile motion or two-dimensional kinematics. I'm gonna make this bigger, make this like 14 bold and underlined. That's kind of silly, but whatever. All right. And then you just keep doing it. There's the solution, there's the problem, you keep going. All right. None of these multiple choice questions are going to be very long. They're all, the calculations on these are typically just one equation, plug and chug. Some of them aren't. Some of the later ones require more work. But at the end of the day, your quizzes and your final are going to rely on these questions that we put in here. Okay. I'm going to take these questions and use them for your final exam. I'm going to change numbers up, but or setups up a little bit, but I'm going to pull from this file for your final exam and any quizzes we do, pretty much. Not completely, but I am going to pull from these. Okay. Well over half the questions on your final, if not 75% of your questions on your final, will be these, but revamped a bit. All right, so that's what you're going to do. Those are the instructions. Don't change in the formatting stuff. Don't be goofy in here. All right, I'm going to make these assignments worth a good amount of points, more than the quiz. These are probably going to be like 5 points each one of these. But you're going to have like a couple of them a week. Well, maybe I'll make them 10 points just to make sure everybody takes them seriously and does them. And then the quiz is worth 5. All right, so do a nice job. Write up your solution. If you have to do it on scrap paper and rewrite it, do that. Make it look nice. Everybody's going to see it. So if you want me to go over it and shoot me an email. All right, shoot me an email if you want me to take a look at your solution and tell you what I think. Okay. All right. Can't wait to see you guys sometime. I'll have to do a Zoom session at some point here next week. That'd be good. I'll catch you guys later. See ya.